Good afternoon, everyone. First of all, I would like to thank all of you for attending my talk and also giving your time to, giving me time to explain or share what I really value in the final field. So yeah, so my talk is about peek inside the pixels, visual interpretability for computer vision models. There we go. So everyone here have played with computer vision before? One, two, three, 3,000. Okay, that's a lot of people. Yeah. Okay, so yeah, before that, I'll introduce myself again. Yeah, I'm Cyrus, and currently I work at Accenture, but next week I'll be starting at Cambridge. Yeah, and also I teach data science, and I've been a volunteer at PyCon Philippines since 2023, so that's around 2 years. And on my second year of volunteering, I get to co-chair the APAC PyCon. So if everyone here is interested, definitely you can volunteer in your local PyCon meetups, and you'll never know if you're going to be the next, chair. And definitely the most wild experience of my life. And I'm very sorry for this very shameful plug, but we'll be hosting Python Asia in the Philippines again. If you're interested, please you can book your tickets ahead or something. But yeah. Well, more details will be shared in our Facebook page, Python Philippines. Thank you so much. Okay, there we go. So with the rise of generative AI, a lot of people have shifted the focus to text image models or LLMs, right? But computer vision remains a fascinating field, and at least for me, because it's all about how machines see the world, right? So in this talk, I want to explore how we can get beyond those usual metrics. If you know accuracy, precision, recall, if you're a data scientist, I know you like prioritize these metrics, but in the field of computer vision, it's not just about those. And I want to share how we can actually interpret that, interpret what the model is learning. So I won't be showing any code, well, a little bit, but there's a demo where where you guys can interact with the demos that I made. Okay. So yeah, accuracy isn't understanding. So when you evaluate models, we often rely on metrics such as accuracy, F1 score, and anything. Yes, those are important, but they only tell us how well a model performs, but not why it performs that way. So take this classic example. Let's say, there we go. Let's say I want to train a model that can identify Hong Kong banknotes. So I know you have 20, 50, 100, 500, 1,000, right? Okay, thank you for that. Okay, so after training, okay, so you gave the model a lot of images of banknotes, and you see it achieves 95% accuracy. Well, that's great. But when we visualize its attention, or when we try, or when we think of it like, how does it say that it's a 100, it's a 20? So there are a lot of features, right? So you can determine a banknote depending on its colors, right? So a lot of banknotes, different colors. The denomination, right? So let's say my camera is not that great and the output is this one. So I have a black and white camera. So how will the model learn based on the color if I remove the color itself? See, So will the accuracy be still the same? Of course not. That's why we need to that's why we need to think of ways for the model to learn on other features rather than something obvious, right? Okay, so of course, there's like a movement where we do ethical AI or interpretable AI or meaning or XAI, explainable AI. So in computer vision, maybe I have some 3 pointers. So interpretability matters. So first is the trust. So if we can see what the model focuses on, we gain confidence that it's learning the right concepts. It's not just random patterns that it saw during training. Debugging, so when a model has or makes these strange predictions, at least you can see where it is focusing on, and maybe you can fix it yourself by giving it some new data, or let's say next is bias detection, where sometimes models do unintentionally learn on social or environmental bias. So that depends on what data that you give on that model. So it's like associating like certain colors or certain contexts with specific outcomes. So when visualizing the model's focus, it's often the first step to noticing these problems. So interpretability isn't just curiosity, but it's essential in responsible AI. Okay, okay, yeah. So to understand more of computer vision models, yeah, so this mainly what they use. I won't explain architecture because it will get too technical, and I don't want to. That's not my intention for this talk. But yeah, so basically, what we see computer vision models, it uses CNNs, or what we call convolutional neural networks. Where in the early layers, so you can see there are a lot of layers there. They just detect simple edges, textures, and maybe in the middle layer, they can detect shapes, maybe some parts of the image, and then in the deeper layers, where they can capture whole objects or concepts, and it's like how our own visual cortex builds up perception step by step. So yeah, the next is VITs. So actually, this is a more modern way of doing computer vision. So it's like CNN, but you combine it with transformers. So that's why we call vision transformers. So VITs or vision transformers, on the other hand, sees the whole world differently. So they split the image into patches. So that's the them right there. So you can think of it like puzzle pieces and use attention to decide which patches are most relevant. So instead of scanning with filters, VIPs, you can say they look around and figure out relationships between regions of the image. So both models are hard to interpret directly. So that's why we need visualization tools that help us look into these hidden representations and see what part of the image is influenced is influenced on a decision. Okay, so this is our first tool that we can use to interpret computer vision models. So it's called Grad-CAM, or gradient weighted class activation mapping, and it just basically shows us which parts of an image most influence a model's decision. So later there's a demo, but I'll explain first how this works on a high level. So when an image passes through the network, right, the CNN, like I explained earlier, there are layers that can detect edges, textures, shapes. Grad-CAM looks at the gradients, so gradients meaning the colors right there of the output with respect to the final feature maps or with the actual prediction. And these gradients act like importance weights. So they tell us which regions in the image push the prediction toward a certain class. Okay, so when we combine these weighted features into a heat map, warmer colors mean stronger influence, and cooler colors means no influence at all. So when we apply it to, let's say, a Hong Kong dollar classifier, if the heat map glows over the denomination number, you can say that that's good. It's the model is focusing on the right details. But if it's fixated on something like a serial number or a logo, those features are not really what you see on or how you identify backlinks, right? So maybe probably it's just learning shortcuts when predicting those backlinks. So Grad-CAM really helps us visually by checking what parts of the image the model is truly paying attention to. So you guys can hear code here. I created a streamlit demo. So I think it's functional, but it's not perfect because I just made it last night through live coding. So I just noticed that I can't use ChatGPT here or something, but I use DeepSeek, but that's okay. So yeah, everyone can follow along just by doing the demo, by accessing the QR code. Yeah, I was debating if I should show the code or not, but I think the code would make this talk a bit longer and it would bore the hell out of these. No, yeah. So, yeah, so again, this is just a beginner-friendly talk. Well, I intended it to. So, yeah, if you're interested in the code, I think there's a button on the upper right corner of Streamlit where you can see the chaos in GitHub. I think, yeah, feel free to play around with the demo. So first thing that it always do, of course, when we code in PyCon, we always install libraries that we need. So the particular library that we need is called Grad-CAM. I think PyTorch has this by default. But yeah, other dependencies there are Torch, of course, Torch Vision, Mat.lib. We need that to do the visualizations. OpenCV, Pillow to open the images, and of course NumPy. And then, yeah, so I want to show the code, and then we're going to load the model. So well, you can see there, but the model that I use is called ResNet50. So it's a predate model that can recognize a lot of objects. So yeah, it's already trained in millions of images. So I just imported that from PyTorch to make things simpler. Okay, there you go. Next, of course you have to prepare the image. So the model needs the image in a specific format. So if you can see there in the demo, there are like buttons that you can click, and then you can also upload, or not upload, but you can give it a link, and maybe you can extract the image from that URL. So basically, we just convert the input image into something that the model can read. The rest, the thing that we can use, that we're going to use for detecting this image. Yeah. Okay, so here's the code. Grad-CAM. Um, you can tell Grad-CAM which layer of the neural network to look at. So this varies on the model. So ResNet, I think it only has 4 layers. And at the fourth layer, at the end of it, there's the prediction layer. So that's where the answers will come from. So different models will have um, different last layers, so you have to identify that yourselves. Um, but yeah, you just have to point the Grad-CAM into that last layer for it to visualize what it needs. Yep. Okay, and after that, um, the heat map will be generated, so that will come from Grad-CAM. It will analyze what parts of the image the model is looking at, I guess, when making its decision. So the result is a heat map showing which areas of the image are most important when creating that decision. Then at the end, we just compared the original image and the Grad-CAM visualization. So you just tone the image down a bit. Then you can see there when predicting a cat, so it will most likely look at around the face area. So you can also try coffee, the coffee image. So it will focus on what's on the cup, well, not the cup itself. What else? I think I have elephant there and a dog, 2 dogs. Yeah. Okay, so that's Grad-CAM. Basically heat maps. And from those heat maps, you can see where does the model look at. So I'm looking at here when predicting. Okay, so that's it. Okay, so next is LIME, or we call it a local interpretable model agnostic explanation. So this one, from the name itself, model agnostic. So you can choose any machine learning model that you can think of, and you can use LIME on it. So basically, LIME helps us understand why a model made a specific prediction. So instead of looking for the entire dataset or the full model, LIME focuses on just one prediction. Like why the model said this is a tree frog. It works by slightly changing the parts of the input. For example, you can hide, the body. You can hide parts of the image. You can alter small image. You can alter the small regions in the image, and it will observe how the prediction will change based on those small iterations. So from those reactions, LIME builds a simple but interpretable model that shows which part of the input had the most influence on that decision. Demo. Yeah, so you can, I also have a demo for LIME. I'll give you guys time to scan if you want to follow. But yeah, so the QR code will be shown in each slide. So for you guys to catch up. Okay. I already skipped the other parts because it's always the same thing. You just have to import the library, prepare your image, what else? You call the object. So basically that's what Python is, right? You just call the library, then the task is done. Yeah. So LIME needs a function that takes images and then returns the prediction probabilities. So if you would like to see the code also, it's also in the GitHub if you press the upper right button. So basically the function that I did there was it will pre-process each image Again, the model takes a specific kind of um, input for it to predict correctly, and then it will run through the model, and then it will return the confidence to each possible object. Okay, so in here, we just set up the line and then generate the explanation. So you can create a line by just calling the object. So this object is called line image explainer, blah blah blah. Line creates many slightly changed versions of the image. So like what I said earlier, you might have images that is cropped out, the face is blocked out, or there are parts of the picture that is that is missing, and most likely that will sorry yeah, so the predictions will come from the outputs of those cropped images. And it then figures out which regions are most important for the prediction just by removing those regions. And yeah, there we go. So there's also an output here. So it's quite different from Grad-CAM, because in here you can see which regions definitely is a coffee or not a coffee. Yeah, so maybe you can see the green part, so that's most likely what drives the whole decision, and then what's not is the red part, because I think ResNet has a class where it can detect plants or pots, but that's not what we're looking for in the image. So that's why it just trace it around and then put something red in it. Okay, so when do we use Grad-CAM or LIME? So you can use Grad-CAM if you're going to just use CNN. So that's prerequisite for Grad-CAM. And then you just need a fast, efficient explanation because everything is just right there. Grad-CAM is already built in with PyTorch. Yeah, you want coherent object level explanations. So every time you run the model or you run Grad-CAM, you always get the same results. And then faithfulness is your top priority. So since it uses like internal gradients, so it's just within the image, within the model, it's often more truthful. A more truthful representation of what the model actually computed. Then, yeah, can you use LIME if your model is a black box and not a CNN. So again, it's just model agnostic, so you can use it in any model that you want. So yeah, LIME can also explain random forest, SVMs, SVMs, and proprietary APIs. Yeah, so if you need explanation beyond, let's say, image classifications, and you can use LIME. It can also be used in tabular data. You can also use it if you want to understand the effect of removing specific parts, which what I explained earlier what LIME does. And if you're okay with a slower computation, yeah, definitely you can use LIME. Okay, so now we know how to see how the model works or how the model makes a decision. So how do we change it? So how do we instruct the model to learn other features? So there's like two levels here. They're like data model and the model, data level and model level. So you can change whatever you want here. So if you're going to edit on the data level, you can use data augmentation. Maybe in the images you can flip it around, you can crop it, you can add jitters to the colors, And also you can also balance the data sets and remove those accidental correlations, like removing the background, making it more simpler for the model to learn. And also, you can also even use saliency-aware augmentations. So you can apply transformations only to the irrelevant parts of the image, like let's say the background or something like that. And then you can also do some model level iterations. Maybe you can add regularization methods, which can reduce the model's dependencies on highly localized features. And we then get to demo the VIT, because I think I won't have too much time. But yeah, and finally, the results of the interpretability can be feedback into retraining. And if we see the model focusing on wrong regions, we can like fine tune it with counter examples. Okay. And yes, some final words for me. Accuracy isn't understanding. So definitely there's some ways to understand, to see how computers understand things. And visualization, there's a typo. Just imagine there's a T right there. Yes, I guess I did that earlier. Yeah, it reveals insights, just like any other data visualization tools. And then interpretability can guide improvement, since you can see visually where the model goes. And yeah, I think that's it for me. I think I have exhausted my 30 minutes. If you have any questions, you can ask me personally. Yeah, so that's all for me. You can connect me on LinkedIn. Yes, my LinkedIn page is not a phishing link.
I tried to skip you out, you said you do not have access to the apps.
I see. That's unfortunate. So is everybody having the same issue?
First time if you open on the laptop it works.
Mm.
But if we're on phone it's or maybe there's too many people on it.
Yeah, it's always as well. That's good. Yeah, you can connect me on LinkedIn if you have any questions. Yeah, just that's all.